In this video, I'm planning to explain 0 times infinity and infinity minus infinity. First, we are starting with 0 times infinity. And here the first question is limit x tends to infinity, x times sine 1 over x. Let me explain firstly how it is infinity times 0. When you replace the value x, instead of x I'm writing infinity, times sine 1 over infinity, and this is going to be equal to 0, 1 over infinity. If you remember, it approaches to 0, that's why we said it's equal to limit of it's equal to 0, and infinity times sine 0 it's going to be. Sine 0 is equal to 0, so this is infinity times 0. Case is going to be. Okay, and how we are going to solve this kind of questions? This kind of questions, a bit tricky questions. We are going to use some tricks here, like here limit x tends to infinity, x times sine 1 over x is going to be limit x tends to infinity and sine 1 over x. When this x goes to denominator, it's written as 1 over x, and instead of this x I'm writing 1 over x and sine x over 1 over x. Now it is 0 over 0 indeterminate form, and when x tends to infinity, this is sine 1 over infinity, 1 over infinity, 0 over 0. So this expression sine t over t, limit x t tends to 0, because when x tends to infinity, t tends to 0. I used, instead of 1 over x, t transformation. When 1 over x, if I say t, when x tends to infinity, t tends to 0, it's going to be. So this question becomes limit t tends to 0 sine t over t, which is equal to 1. Okay. This same kind of question, limit x tends to 0, 2x times cotangent x. We are going to do trick here again, and the trick here, limit x tends to 0. Firstly, let me show this one here. 2 times 0 times cotangent 0. Cotangent 0, we know that is equal to infinity, so this is equal to 0 times infinity case again. And instead of cotangent x, I'm going to write cotangent x is equal to 1 over tangent x. Tangent x it's going to be, and the expression becomes like this: 2x over tangent x. And if you remember from the limit combination theorem, we can write this one like this: limit x tends to 0, 1 over tangent x over 2x, and that's going to be equal to limit x tends to 0, 1, which is equal to also 1 over limit x tends to 0 tangent x over 2x. It's going to be, you know, from the trigonometric indeterminate forms, this is equal to 1 over 2. This is equal to 1, and this is equal to 1 over 2. It's going to be, so the answer is going to be equal to 2 with respect 1 over 2 is going to be equal to 2. Okay, now we are starting infinity minus infinity forms. Infinity minus infinity forms a bit different. Here 1 over, when you approach to 1, 1 square minus 1, it's equal to 2 over 0, which is approximately when x tends to 1, the limit is going to be equal to infinity, and here it's equal to 1 over 1 minus 1, it's equal to 0, and that's also infinity. Infinity minus infinity case this is. And how to solve this kind of questions? We are going to make some tricks here, or operational orders we are going to apply. X squared minus 1 and x minus 1, we know that they have common factors, which is x minus 1. So if I multiply x squared minus 1, or if I multiply x minus 1 by x plus 1, I will get x squared minus 1. So it's going to be equal to limit x tends to 1, 2 over x squared minus 1 minus x plus 1 over x minus 1 times x plus 1 is going to be. And here, when we make the denominators same, we can simplify the expression. X is equal to 1, 2 minus x minus 1 over x squared minus 1 it's going to be, because the multiplication result of this expression is going to be equal to x squared minus 1. You know this one very well. Okay, then 2 minus x minus 1, it's going to be equal to 1 minus x, limit x tends to 1, x tends to 1, and 1 minus x over x squared minus 1 it's going to be. As you see here, 1 minus, you can factorize x squared minus 1 as x plus 1 times x minus 1. As you see here, limit x tends to 1, 1 minus x over x minus 1 times x plus 1 is going to be. Okay, now 1 minus x and x minus 1, they are multiplicative inverse. So when you simplify these two, when you write here 1, you should write here minus 1, because x minus 1 and 1 minus x, they are additive inverse. Sorry, not multiplicative inverse. Additive inverse they are going to be, and this is going to be limit x tends to 1 minus 1 over x plus 1 it's going to be. When you apply 1 here, minus 1 over 1 plus 1, that's equal to minus 1 over 2 is the answer of the limit of this question. Here, the important part, you cannot add the functions, you cannot add these functions if it is given in this form. But limit allows to do operation on the functions to us. Now we have here one expression, square root of ax squared plus bx plus 3 for the limit, and x tends to infinity here. Plus or minus is not important. A should be greater than 0. This is also important. And there is a formula for this one, and we have to learn this formula by heart. We have to memorize it. So if I apply the formula to this question, because the questions, as you see, square root of ax squared plus bx and c here, and c is not important here, let me tell you, only square root of a in absolute value, x plus b over 2a it's going to be. So let's find what is the expression here, and a here for the first one, a is equal to 4 and b is equal to 8. So the expression is going to be equal to limit x tends to infinity, square root of 4 times, in absolute value, x plus b is equal to 8 over 2 times 4 minus square root of 4 times, in absolute value, x plus b is here, b is equal to minus 3, a is equal to 4 again. For this question I didn't write that one. For this part it's equal to minus 3 over 2 times 4 again is going to be. Okay, then here limit x tends to infinity. Here that's going to be equal to root of 4 2 times, in absolute value x plus 8 over 8 it's equal to 1 minus 2 times again root of 4 2 times absolute value of x minus 3 over 8 it's going to be. Now I have to decide about the sign of the absolute value. Is it going to be plus or minus? When you take the absolute value signs out, you should decide about that one. We are going to decide with respect to this value, which is x, and x tends to plus infinity. If it tends to plus infinity, it means that 2 times x plus 1, it should be here with plus sign, because it tends to plus infinity. The result of this expression is going to be plus. So minus 2 times x minus 3 over 8, it's going to be. Also this side is same. Then this is with limit, of course, x tends to infinity it must be, and the expression, it should be equal to, sorry for the gap here, and limit x tends to infinity 2x plus 2 minus 2x minus 6 over 8, which is 3 over 4 for us. Pardon, this is going to be plus 2x and minus 2x. We simplify, the answer is going to be equal to the limit x tends to infinity 2 plus 3 over 4, that's equal to 2 times 4, 4 times 2, 8 plus 3, 11 over 4, it's going to be. Here we don't have any variable, that's why constant value accepted as the limit value. Okay, now let's solve the similar question here, and this is the last question for us. We are going to apply the same rule, root of limit x tends to infinity, root of a over, times absolute value of x plus b over 2a formula. We are going to apply for the ax squared plus bx plus c form. Okay, this is going to be equal to limit x tends to infinity. Again, I'm reminding about the formula. Here it is the formula. Then it's going to be equal to, here is the formula, and with respect to this formula, I'm going to, this is for this one, a is equal to 2 and b is equal to minus 6. For this one, a is equal to 4 and b is equal to 3. With respect to these, I'm going to write this one, but here a is equal to 4. I made a mistake. Okay, then this is going to be equal to root of 4 times x plus minus 6 over 2 times 4 plus, minus root of 4 times x plus b is equal to 3, b over 3 over 2 times 4 is going to be again. Okay, then it's going to be equal to 2 here, root of 4 is going to be equal to 2, limit x tends to infinity 2 times x plus, when you simplify this to, or there's no need to simplify because we are going to simplify later, and minus 6 over 8 it's going to be minus 2 times, this should be also root of 4 but I forget, 2 times absolute value of x plus 3 over 8. As I told you before, we should take these absolute values out, but we have to be careful about the sign of it. Here the sign, it shows us x tends to infinity. When you put here infinity, the result is positive, so you should take out as positive of the expression 2x plus minus 6 over 8 and minus 2x and minus 2 times x plus 3 over 8 is going to be. Then this is equal to limit x tends to infinity 2x plus minus 12 over, or here minus 12 over 8 when we multiply, we are multiplying by the numerator, you know that one, and minus 2x minus 6 over 8 is going to be. And when you simplify this 2, here we are going to have limit x tends to infinity, minus 12 over 8 or minus 6 over 8 it's going to be, and this is equal to minus 18 over 8. And when you simplify this 2, that's why I didn't simplify here before. I explained here I didn't simplify because I want the common denominator here, and minus 18 and 8, if it is equal to, we have 18 over 8 and it's equal to minus 9 over 4 it must be.